I'm building an omnidirectional tractor out of spare parts and scrap metal in my garage, and today we get it running. So I'll be mounting one up and one down, sort of like this. This is a wheelchair restraint system from a Japanese van. Flick a switch and apply some power to it, and they lock into place. So the plan is to mount this somewhere underneath the subframe, and then I can attach one of these to each wheel. Let's get this mounted, get the starter motors mounted up, and then we can start putting horsepower in it. So I'll bring you down under here first and show you the steering lockout mechanism. That's it, mounted underneath the bottom of the subframe there. You can see the cables running out to attachment points on each end of the tie rod, and then as the wheels turn, one of those cables gets longer and one gets shorter. And once that's locked down, it can't steer at all. I had to turn these pulleys sideways so the cables will be coming out the right direction, but it seems to work pretty well. Up here the starter motors are mounted. It's just a bit of flat plate with the cutout of the starter motor on it. I wasn't confident I could get them on in exactly the right position, so there's a pivot point up here and a turnbuckle here for adjustable engagement of the teeth on that flywheel. I'm not showing footage of all this being built because it's pretty boring, mostly just me holding a starter motor and looking confused. And I know what you and I both want to see is getting the engine mounted, and that's going to live in this space in here. So let's get started on that. Okay, engine is in. Got the fuel tank off it because I'm planning on there being a platform there that I'll stand on to operate this thing, and it's going to be impossible to fill up with it there, so I'll relocate that somewhere else. I may need to do something clever with the air filter. I suspect that's going to hit the chassis rail when it articulates over, so I'll check that out, and I can plumb that somewhere else if I need to, but longer one that comes over here or something. That won't be an issue. But it's in, it's bolted down, and we're now in a position where we can start putting in the transmission and all the chain drives and things that are going to live over on this side. So it's off to a lathe again. Before we get there though, I've got to take the centers out of these sprockets. We did try this in Zach's lathe, but that just made it mad, so we're trying it at home on the drill press with the hole saw, which is equally fruitless. You can see how much pressure I'm putting on this and it's just doing absolutely nothing. So I had to come up with a new plan. Because they're hardened steel, they just don't cut with any kind of normal tooling. So throw them in the oven for a few hours and they come out soft and delicious. And then we can cut through them just fine. Oh, I just want you to give me a smile and a wave so I can give you some credit in the video. This is my stepfather, John. Like myself, John wears many hats. Today he's being a fitter and turner and helping me making all of these flange adapters and sprocket adapters I need to get this drivetrain in. We spent a full day on my granddad's lathe turning bits of flat plate into flange adapters for sprockets. A trick that I thought of, I don't know if I invented it, but I thought of it, was to turn down a shoulder on the flange so that the sprocket locates in the center and then use the sprocket to drill the bolt pattern. It's just as accurate as using a mill, but doesn't require a mill. Now the original plan was for the gearbox to live here somewhere. Chain drive from the engine to drive the gearbox, and then this jack shaft was going to live up here somewhere. So that gives me one gear ratio between these two on the output of the gearbox, and one gear ratio here between this one and this one. So I could loosen the chain, move it between the sprockets, and then it gives me a high and a low range, and then run two chains from here down to the double sprocket on the diff pinion. Problem is, this is taking up quite a lot more space than I was anticipating. And if you have a look, this is a pulley on the engine because I need to run an alternator off here. So I think I'm going to forego the jack shaft and just run two chains, one from the engine to the transmission and then one from the transmission down to the diff pinion. To get the most amount of gear reduction, I'm going to put one of these larger sprockets on here. Alright, we'll get this sprocket off, put this bolt pattern in it, and then we can mount the gold sprocket onto the diff pinion and mount our gearbox. Annoyingly, the bolt pattern I need to drill half overlaps 4 bolt holes that are already in this sprocket, so I've got to grind off the coating and weld them up before I can re-drill them. With that done, I can move on to mounting the gearbox. This clip is being recorded on my 4K action camera. If you're a purveyor of 4K cameras that are actually 4K and you want to support the show, you can contact me at weldeddaydreams.com/contact. You can see here I'm putting these two stainless offcuts in the saw at the same time. Don't try this at home. It's okay when I do it because I'm not at your home. So the alternator's on, but I'm not happy with it. Being tensioned up to this point here gives it too much flex, and the mounting point that I made for the pivot point on the bottom, out of those two stainless offcuts, there it is, the hole in them is too big for a 10mm bolt that mounts it on there, so it's got a bit of play in it. So I'm going to redo that. I think I can do it better. I need to clock it forwards so that this point here can be lower and that doesn't bind up with the ear on the alternator, and then I'll tension it off that cross member there. I'll make something that comes up that way, and this point here, to clock it forwards, I'll move this mounting point further up here into this space, so that the whole thing can be rotated that way. Knock that out, then we'll move on. If you're enjoying this video, consider leaving me a like or comment or subscribing to the channel. It's free and really helps out our Algor's rhythm. If you're interested, there's some more content over on my Patreon. I've put a link in the description. Some of it's free, some of it's not, or you can find me on a handful of other platforms. Okay, alternator is done and mounted. Obviously this needs to be trimmed down, but I can't get the grinder in there, so wait till the engine and gearbox comes out as part of the final strip down to weld it up, and I'll cut that down then. Mount underneath looks excellent. Is holding it back there so that there's plenty of room in that adjuster, and that belt is nice and tight. Drive chains are on. I'm still not sure I believe this. These two are actually the same chain. I bought one length of chain and it was the exact right length to go on the secondary drive and the primary drive. And even weirder, the primary drive is exactly the right length to not need a tensioner. Unbelievable. You wouldn't read about it. I do need to put one on here, and I'm waiting on a little idler sprocket to come in the post. But apart from that, the drive system is done. The last step is going to be to build an exhaust and an intake. I've had to remove them off the top here just because they were bulky and in the way. This is the factory muffler with all of the heat shielding cage removed off it. I think I am going to use this just to keep the exhaust back pressure the same so it doesn't need a retune. Partly because I don't want to retune it, and also because if I give it any more power the gearbox will break. Problem is, I don't have any bends. I've only got straight pieces of tube. So to get that out there, I'm going to have to try my hand at pie cuts. So let's give that a crack and see how well that works. Now if you're more attentive than I am, you may have noticed a problem with that plan. To get the clearance to make the exhaust, I need to cut down that piece of channel, which I can't do until I tear the whole thing down for final welding and paint. So we're going to do that first. Here's the subframe completely stripped down and welded up. I've added in some support plates underneath the gearbox mounts here and here, just to stop them parallelogramming under the torque of the engine. I'm also capping off the ends of that front tube on the subframe. It just looks incomplete without it. I can't put my finger on why. Once that was done, I carried it round to the backyard to paint it. It looks like I'm struggling to carry this. It's because I am. It only weighs in at 50 kilos, but it's such a ridiculous, awkward shape to try and maneuver. I'm going to have a talk to the bloke that designed it, I think. A quick splash of paint, and it's ready for final assembly. Now there's a fair bit of assembly to go here, and many hands make light work, so let's try something different. Okay, let's make an exhaust for this thing. The first thing you'll need is a flange for the engine. In my case, I need one for the muffler too. Start with a clean bit of steel plate and trace out the factory exhaust gaskets. Then mark the center of the bolt holes and the exhaust port. Pull those out. And then cut out the shape of the flange. If you've done it right, it should look something like this. Now a pie cut is basically a straight bit of tube cut on an angle at both ends, so you can stack a few of them together and make a kind of curve. Here I'm using 15-degree cuts, so each section covers 30 degrees, but you can change the shape of the curve by varying the length of the tube or the angle of the cut. And with enough stuffing around, you can get something in pretty much whatever shape you need it to be. Going to have a bit of a play with the articulation and work out how much space I've got here, but I like the idea of having a little dump that goes off the side there, more towards the back, but we'll see how that goes. I'll get that off and weld it up and we can move on. Once your exhaust is airtight, give the flanges a good sand on a belt sander like this. It takes out any warping from the welding and helps it seal tight against the head surface. You're looking for a smooth, even finish across the face of the flange. This one obviously needs a bit longer. If you're making a turbo manifold or an intake, make sure you deburr the edges of the cuts before you weld it together, or things will get expensive. On the home stretch now, the last thing I need to do before I give it a test fire is make a tensioner for this chain, because it's loose and floppy and we can't have that. Now normally when you're tensioning a chain you use a skateboard wheel or one of these little bobbins, and these work fine. They take up the slap and stop it from flapping around and coming off the sprocket. Problem is, this is a Ford reverse gearbox, which means the chain is going to be alternately tight and loose on each side depending which direction I'm driving. And these little plastic bobbins need to go on the loose side of the chain, especially when you're dealing with this much gear reduction. So I bought a couple of these. Just a idler gear sprocket with a with a bearing in it, and the plan was for that to sit in there. Now, I don't know how well you can see on camera, but that gear doesn't fit into that chain. This is an 08B sprocket, and that's 420 chain. I was hoping it'd be near enough, but it's not. But what I noticed was these sprockets fit perfectly into this gear. It's almost a perfect fit. So what I've done is trim the teeth off one of them, and I'm going to weld this onto that gear, and then I've got an idler sprocket, and I can make a little tensioner using another one of these turnbuckles, and then we can give it a test fire. What I'm doing here is just welding little bits of it at a time and then dunking it into a bucket of water so as not to overheat that bearing. Ideally, you would remove the bearing and then weld it up and put the bearing back in, but I haven't got a circlip tool. And the driveline is done. You would have just seen I ultimately decided not to use the turnbuckle and just opt for a regular sliding style tensioner. It's I think it'll be okay in this application. I wasn't sure about holding back the tension on that chain with just friction when it's pulling it tight, but the tensioner is running almost parallel to the chain, so there's not a lot of force going in the direction it can slide. If I really need to, I can still put the turnbuckle in for some positive mechanical lock and sink it down into there, but I think it'll be fine. Just about to tip some fuel in it. You can see I got the fuel tank fitted just temporarily. It can't live there with what else is happening, but it's on there for now. I'm about to tip some fuel in it and fire it up for the first time. It's probably going to be a bit smoky. The engine hasn't run in a while and it's been moved around a bit, but once it clears up, I'm hoping it runs pretty good. Well, it ran on the degreaser.
There you go, run on the degreaser. Fill the tank with degreaser.
Eventually I gave up with the pull start and got the drill out. Well, that looks like it's all it's going to give us. I'll pull the carb off and give it a good clean out so we can get it running. Next episode, you'll see that, as well as building or starting to build the control interface. So that's a flying bridge with this barbecue. Why does a tractor need a barbecue? Have to tune in next time. Thanks for watching. And that'll give me some space for other activities. First you don't succeed, remove all evidence that you tried. And there goes the power.
Maybe a funnel way?
Yeah.
That most of the petrol goes in the tank.
I'm pretty sure this is the kill circuit. So I can touch these together and it'll stop.
Pretty sure.
Pretty sure.
I'll stand behind this rusty bar piece of protection.
Good plan.
So, this is why you got big arms and backs, because none of your shit starts on the first go.
Yeah. It was on fire a bit. Well, I guess I'm hooking up the electric start then.
Yeah, cut.